Appreciate it, Tom. And I think you've got a voting thing as well.
Yeah. I'll show you URL. But yeah, the throwdown. Sometimes you think it's like two folks arguing. I'm SQL. I'm no SQL. So the audience is the one that's going to do the arguing, not me. I'm just going to do the educating, I guess. But a couple of questions real quick. And this is probably better. How many have never used SQL in production? So everybody's used SQL in production. Thought that would be the case. How many people have not used no SQL in production? A few? Okay, about half. Good. So I'm going to go through and first introduce myself. I'm Tom Wilson. I'm founder, president of Jack Russell Software. Also do the CHS Code Camp, and have been doing databases for 20 years, even back to DB3. You remember those? And have used both SQL and NoSQL in production. That's my Twitter at twilson63. 63 is my football number, by the way. So it's like, I'll never forget that. Code Camp, so as Ernest said, is a boot camp that's one day, and it really is sort of the best thing you can get to the matrix, right? So I want to learn about CouchDB, and just cram it in my head. And sure, it's not going to make you an expert overnight, but it should give you a crisp start of exactly where to go through, where to get more information, or if you're interested in getting more information. So again, it's a one full day, and the purpose is for your head to really hurt at the end of the day, right? And you can find out more about it at CHS Code Camp. And it's professionals only, so everybody that will be attending will be a professional software developer. There won't be any students or any non-developers. So what is SQL? Well, SQL has been around for a long time, and it's a relational database, but a lot of folks may think that that's relations as relationships, but it's mathematical. So a lot of math, a lot of calculations go into building a relational database. And then you have structured query language, right? So every single relational database, you actually get data from it using SQL. So every relational database has a common language to get information. And you've got tables, rows, and columns. And then you've got all of this fancy stuff like indexes, views, and stored procedures. We've been working with relational databases for 40 years, so they're very mature, right? And one of the things that's sort of a common thing, and again, this is all relative, but is vertical scaling. So relational databases are meant to just go up on a cluster or one server as high as you can go. If we can put 1,000 gigs of RAM on it, that's how they're meant to perform, right? Now, there's some ways to shard them and get horizontal, but as you do, you lose your features of indexes, views, and stored procedures. So there's always ways to do that. And then you have to have a predefined schema. So you have to know exactly what data you're going to store before you start to code. And again, this may be something that you may think, well, that's pretty easy. Well, we've grown up with these things, but we don't realize how much time that we've spent learning how to do relational databases. And it is very daunting to new developers to come in and say, hey, I know JavaScript or I know Java, but then have to learn how to do SQL, have to learn how indexes work. Some folks don't even know what a view is or a stored procedure is, right? So it is a very steep learning curve. And then the last thing is when you get to some size, you need database administrators. So a lot of companies don't realize that, when you go relational and you get bigger, that you need that gatekeeper who controls your data and manages your data, or a team of them. So that's probably not a big surprise to you guys, but here's some of the players. And the biggest thing is that relational databases create vendor lock-in. Now, that's not 100% true. It's possible to move from Oracle to MySQL, but when you get to a certain size and you're on SQL Server, all your DBAs know SQL Server, all your developers know SQL Server, so when the CEO goes, I hear Oracle's really fast, right? You say, well, that's going to really cost a lot because we're going to have to retrain all of our folks to move over to Oracle, and not only that, change all our code. So relational databases, even though they share a common structured query language, they're very much vendor locked in. Once you commit to one, you're sort of stuck with it. So what is NoSQL? Can anyone give me a definition of NoSQL? Anyone? It's real easy.
There isn't a definition?
Yeah, it's not a relational database, right? So anything that's not a relational database, right? You have a key value store. And these are just genres, right? So there's also a lot more, but I'm going to just cover 4 today. Key value, document, columnar, and graph databases. So columnar, thank you, PowerPoint. But basically, there's 4 really most popular types. And the interesting thing is, so you break them down into types, but really, we'll see here, as you go through each type, you'll find out that even within the types, like Riak and Redis, are completely different, right? So you can't just say, hey, we should use a key value store. You have to really look at each particular database to really know what you want. So, but they do allow you to sort of put things in sort of perspective. So key value is basically a store that you assign keys and you assign some value to it. Now that value does not have to be structured. And they're simple, they're fast. 2 main types, a key and a value, and then they're very much designed for horizontal scale, right? A lot of the key value stores have come from the Amazon Dynamo paper. And a lot of folks, Riak is a good one that's open source that is built purely for scale, so that you can just throw in a node and get more capacity. Memory cache also is a good use for key value stores, and you might know Memcache and Redis. So Riak was based on the Dynamo paper. And one of some of the features of Riak is that it's pure HTTP, so you don't need a driver to connect to it. You can use any HTTP protocol to get data from it. So it's very web friendly, right? It's easy for web developers to learn how to connect to it. Again, horizontal scale. So you start with Riak, you usually throw up at least 3 instances of it to start reading and writing, because it basically writes data in 3 different places, so that if one of them fails, you have it in 2. And it supports, out of the box, 64 nodes, right? So you can scale up to 64, and you can re-provision it to do more. But the first one is up to 64. And it's fault tolerant, right? Riak was built so that if a server goes down at 2 a.m., you can come up in the morning and know that there's not a problem, and just have your coffee, get your donut, then go, okay, now I need to replace that server, piece of cake, put it on another one, and nobody knows anything. It's designed never to go down, basically. And it uses MapReduce, which is a little bit different than SQL. MapReduce is a process where you have a list of keys and you map over them in a loop, and you apply some logic. You say, well, if these keys equal X, then keep them. And then reduce allows you to filter them down into counts or groupings or other things. So it's a very common algorithm in NoSQL databases. Redis. Now, Redis is a key value store, but it's completely different than Riak, right? So it's light and compact. It's a Swiss Army knife. It's got over 120 different commands to do stuff to data, from creating intersections to Z counts to all kinds of sort of array or hash manipulations. So you can really do a lot of interesting things with it. It will be used for transforming data. So if you're using an ETL, it's great to put stuff in it and pull stuff out and use it sort of like a bus. Messages. There's a very popular message queue called REST from the GitHub guys, and they use Riak for messaging and caching. A lot of folks use it for caching or session stores, things like that. The key straight to speed, it puts everything in memory. So it's extremely fast. And it has really a lot more advanced concepts than just key value. It has lists, hashes, and sets. And the last thing is so it puts everything in memory. The biggest size that it can be is how much memory you have, right? So if you have 4 gigs, once it hits 5 gigs, it's going to crash, right? And it's very much designed to be a single server or a cluster replica server solution. It's not designed to scale horizontally, even though it's a key value store. So the next class is document databases, and these are probably the ones that you hear about the most, right, in the NoSQL paradigm. CouchDB and MongoDB. Basically, the difference is they store documents, so you can store complex data. Most of the ones store JSON, JavaScript object notation, and they're schemaless. So if you don't know what your data is going to be when you start to build your app, you can use a document database and start iterating and start building and start doing a very high agile process and let feedback drive your data model. At some point, though, you have to lock it down, right? So it sounds really nice, but at some point you have to make a decision. A very simple API, right? So MongoDB is made for developers, right? And it's web and cloud friendly. So MongoDB is probably the very most popular NoSQL database, hands down, and it's schemaless. And one of the differences from the other ones is it's got a very unique and rich ad hoc query language. So it's very much like where clauses in SQL, and it allows you to do ad hoc queries faster than any other system out there. Strong driver support. It does have binary drivers, so you have to download the drivers with all your languages. But they've really gone to a great length to make sure that these drivers are there. One thing to note, though, is you've got to make sure you always have the right driver version with the right server version, because they do not always go backwards compatible. So oftentimes you might say, oh, I just updated a database and now my app doesn't work. Check your drivers, cables, and connectors. Developer friendly. This is probably the biggest feature of Mongo, is that it is so simple for a developer to grab it and start writing data to it. It's probably the least resistant of database, and you don't have to know anything about databases, right? You can just grab it and go. And it supports large clusters, and it's a great gateway from object relational mappers, or ORM. So if you use any kind of MVC framework to build your app, this is a great product. It was specifically built to be designed for that back end of the model view controller paradigm. The one thing that is a little bit of a weakness of it is that it is quite complicated once you get to scale to sysadmin, right? It is not super easy to administrate. When I say super easy, you probably need a DBA to do this. It's not something that can just keep itself up to date. CouchDB. CouchDB is a document database store, and it basically is a little bit different than Mongo, where its core philosophy is to be built for the web. And what is the web? The web is unreliable networks, right? As everyone has probably experienced the last few days with the rain. It rains, the network dies, right? But they're faulty, they're unreliable, and you can't really depend on them. So why should you build software that thinks that they're going to be connected all the time? You build software, especially if you've looked at cloud computing, everything is made to build to fail. The thing is to manage that failure. So Couch is the same way. It's built and says, hey, I know that things are going to fail, so I'm going to use an HTTP interface, and then I'm going to be a very small or a very big footprint. And Big Couch is recently merging with Couch. They've merged, and now that introduces clustering. So that really opens up CouchDB to really compete with the Mongos in the big data build of document databases. And the best feature of Couch is replication. So to set up a Couch database on the East Coast and the West Coast, and to have them mirror each other and create master-master relationships is far simpler than any other system you'll ever come across. It is so simple. So, and as we see in the future, more and more demand for users to ask, hey, the web is broken, but when I'm on my phone and I'm using my app, I still want to write my data, right? So this concept of offline is going to become more and more prevalent, right? So the Couch comes up with a custom API that's very RESTful that allows you to actually put Couch on your mobile phone, Couch in the cloud, and then your user can write to that Couch. And then when the connection comes back, it can behind the scenes send it up to the server. And guess what? The user's happy, because when they're storing their important information, when they're taking that picture of the dinner that they're fixing to have at some great restaurant, they want it to say, be happy and say, okay, you've got it. And once they leave the restaurant and establish a connection, then shoot it out to Instagram or somewhere. Okay, so now these are a little bit more confusing. You guys, everybody with me so far? Anybody lost? Okay, good. Columnar databases. A while back, the super smart guys at Google came up with this big table paper. And the columnar databases are largely based off of that big table concept. And basically, if you think where rows are first-class citizens in relational databases, columns are first-class citizens in columnar databases. And they're very dynamic, so you can add columns and you can have certain rows of data that have variable different columns, but they're not complex structures like you would think in a document store. But they allow for versioning and consistency and incredible horizontal scale. Great for logs, great for lots of big data. All of the big data groups like Twitter and I want to say Tumblr, but I can't remember if it's Tumblr or another one, but they actually use this because they have so much data to deal with. And a couple, Cassandra, Facebook, built Cassandra because they had so much data. But basically, they're built to handle and query a lot of data. HBase is open source, and I don't think it's the most popular right now. But it was pretty popular a few years ago. And it runs on top of Hadoop. And Hadoop is commodity structured storage, right? So you could just take a bunch of servers that are laying around and just basically string them all together and create a Hadoop process. And then HBase runs on top of that and starts to structurally organize those storage data areas. And it supports compression. So even though you have a lot of data, it's very compressed. So you can really maximize your hardware. The interesting thing is you've got to start with at least 5 nodes at a minimum. So when you bring this up, you need 5 processes or 5 servers to start running them. And it's usually part of a bigger system, right? So usually this is not your transactional database that you're storing transactions. This is more like for logs or for reporting or data warehousing or any other sort of back-end things. And there's no sorting or indexing because these things can scale over the thousands, right? Thousands of nodes or some HBase setups. So Graph. Graph is relatively new. How many people have heard of graph databases? Good, good. So this one's really exciting, especially if you're in the social world. Graph databases treats relationships like you would think of relationships, right? So, a patient has medications and a patient has conditions. Those are relationships. And with a graph database, the most easy to understand is Twitter, right? So Twitter, you have followers, and then you follow people. And what the graph database allows you to do is connect all of those to quickly walk graphs to find, okay? On LinkedIn, you probably see it, right? You got 1 degree, 2 degree, 3 degree. Well, they're finding those things out super fast through a graph database. So it's very simple. The data is relational. You have a node and then an edge. And an edge is just a pointer from one node to another node. And that's it. You may see that nodes are called vertexes and edges are called relational or relations. But node edge just works for my brain. And you can get very deep. So you can easily walk graphs and find out like, okay, here's Tom, and here's Bob, and here's all the people that they know, and here's all the people that they don't know, or a couple degrees apart. So you can really walk graphs very quickly, which in SQL it would be like a 14 join query, right? So Neo4j is probably the most popular graph database. They just turned 2.0 just last week, and they're embedded for big data scale. It's interesting though, is big scale is not Facebook scale, right? So they can support up to I want to say they can support 1 billion nodes, but they can't support a social graph of 800 million users, right? And I don't know if there's anything that can, other than Facebook magic. But big scale, I mean, they can support a lot. Easy to add data. I mean, you just add a node. A relationship just needs 2 nodes to connect. So it's super easy. It's super easy to graph. You find one node, you ask it how many children it has. You find the children, you ask it how many children it has. And it's got a little custom query language. But for the most part, it's very easy to pick up. And there's no constraints. It's schemaless. You can add certain elements in it of various types. And it's highly available. There's a little work with Neo4j to get it highly available. It's very much likes to have its data in one area. So when it's highly available, it's not like all over the country. It's more of like more clustering than anything. And there's no sharding, again, because it doesn't like to have to go too far for its data. So that was a whirlwind tour of all the NoSQL databases and all the SQL databases. And now we'll have a challenge. Is everybody doing okay so far? Any questions? Great, great. If you guys can get a connection, go to, let's see. Well, first, basically we're going to go through 3 use cases. And I'll explain more of these in a minute. But a CRM, customer relationship management, basically I think of it as a data-driven app, right? Any application that you have more than one role that needs to access data and your data has relationships. CMS, content management platform. So WordPress is probably the most popular CMS out there. And then social, right? So Twitter, Facebook, LinkedIn. Any kind of social media, social connecting application. So are you ready? you guys have internet access on your cell phones, go to td.twilson63.com, and that'll pull up a little voting app. So you'll be able to participate in this debate and make your voice heard, right? See if I can do this.
Welcome to mobile, Taylor. Welcome to mobile.
It's good to be here, man. I now have internet on my phone.
Well, I'm sorry.
Hopefully, you guys will see Twitter, GitHub, and Persona, so you can log in with either one of those. And once you log in and go through OAuth, you may have to refresh the page, but then you should be able to vote. And it's basically just there so that only one vote per person, right? And it will update real time. So as you vote and other people vote, you'll see what happens. So CRM, like I said, it stands for Customer Relationship Management, but I think of it more as a data-driven app. Again, probably most of what web apps are relating some sort of data and having multiple users log in. A very popular one is Basecamp from 37 Signals. I would call that a CRM, right? So you've got multiple users of different types, and you're adding data. Of course, Salesforce is a popular CRM, right? Or any of the CRM tools. And a lot of stuff, what we do for healthcare is very much fits under CRM because, when you're writing patient data, you have multiple roles that are reading and writing from it. A lot of government applications fit sort of in that wheelhouse. So they're multi-tenant oftentimes. You have multiple different customers. You have multiple roles, right? You want to secure and allow people to see and do specific things based on their role and responsibility. And then for the most part, I would say that it's a moderate write database that you would, between a heavy write to moderate to small, moderate, if you think most time people are putting information in, but not as much as they're consuming it, right? And it's very much a heavy read. So pretty much everyone that logs in the app is there to go and get data and read data, and they want to read it quickly. All right, so we got some votes going on. Good.
Is there any expectation for size, or would this be like deployed somewhere and run with an organization, or is this going to be like hosted and given to anybody? So you've got a plan for like the millions of people using it?
Yeah. Well, I mean, each use case is specific, so I'm really just trying to be general here. So whatever you sort of feel that is, but obviously that's a big play in your decision making, right? All right, so if everyone's finished voting for that, we'll go to the next one. Okay, here we go, best choice. So like you said, if you know that it's only going to be for 3 people, Microsoft Access is a great solution, right? But if you know it's going to be for 1 million, right? So if you're, like a Foursquare, or you're launching to a consumer market, you do have to question some limitations with SQL relational databases. Now, I think you can pretty much make just about any database fit any problem, but I don't think that's the right way to go. I think you really, learning what you're doing and learning and probably, 80, in my opinion, I'm not always right sometimes. but
You choose not to be, right?
That's right. But most of the time, a relational database works really well. Now, MongoDB offers a really interesting play here, too. So I would think that developers could very much argue a MongoDB in this realm as well. Anybody want to care to add their thoughts out loud? No?
I would add that a SQL database is probably a good choice because of the transactional nature of the data you're working with.
Right.
I think a document store NoSQL it tends to be a little more challenging sometimes.
Yeah, SQL Store is ACID compliant, so you can add a bunch of stuff, and something breaks, you can say rollback, right? Where a document store, once you add it, it's there. So you're absolutely right. If you have heavy transactions, like a lot of financial data, relational databases are a really good fit. Okay, so if NoSQL, probably I think everybody sort of feels like document, right? So if it is key value, it would be really hard. Graph would be possible, but hard. Columnar would be just horrible. CMS, content management. Think like a WordPress or a Tumblr or anything that basically you're doing a heavy read. Everybody's consuming it, and low rights, right? So people are producing it, but the amount of people that are producing the content is very small to the amount of people that are reading the content. And sometimes you have very complex structures, but minimal roles, right? You have a consumer and you have a producer. You don't have a lot of roles. And oftentimes, if you think like Tumblr and Google, Gmail, things like that, is multiple tenant, right? So most of the CMSs are built to have multiple customers, right? So let's see. Is everybody able to vote okay?
It's a little wonky.
Yeah. Yeah. Cool. So 9 people say NoSQL, and 1 only says SQL. And I think that's a very good choice. Document databases really, really fit well. Key value databases do fit well here. It airs out. Yeah. Sorry. 2 hours. Give me a break.
Too much data.
Yeah. It's not using a NoSQL store. That's the problem. Or a SQL store. I think with the CMS, I think most people choose document databases at this point in time. And if you may say, well, WordPress is the biggest one and they use relational. Well, when they started, there wasn't really a NoSQL database for them to use, but I guarantee if there was, they would have gone that way. And that sort of goes into vendor lock-in. Once you go SQL, you can't go back. It's very hard. So the next one is sort of social. And social, Twitter, Facebook, LinkedIn, all of these social applications they're very much heavy read and heavy write, right? People are posting their food on Twitter. They're posting why they don't like this talk. They're posting why they can't stand this app. Twitter's great for posting content, but then it's also great for receiving content and getting content back. Sometimes people know that their internet's down because their Facebook feed's turned off or their Twitter feed. Hey, I'm not getting any tweets. So, is there something wrong with the internet, right? Because people are so used to consuming constantly. Simple roles, right? You sign up as a user, and the user can both publish content and consume content. So there's not a lot of complexity there. But it does have heavy data relationships, right? So in social, it's all about connecting, all about, and this is very leading to what the perfect choice is, all about the social graph. You always hear the social graph or graph and who's connected to who's following who. That's pretty much a lot about social databases. And usually you're doing this for a large user base, right? So you want social apps that are successful have millions of users, right? You don't necessarily need a social app for 20 people, right? Because they can use email, right? So, best choice? 10-0. Hands down, NoSQL, right? So out of NoSQL, What do you think?
Graph.
Graph.
Probably graph and a document. I would
Yeah.
think.
Yeah. Graph is still relatively new, so I think that's the right choice. But then if you're conservative, you may want to start with document and just sort of watch graph for a while. And that's one thing to bring up. What's interesting is I keep talking vendor lock-in with SQL. NoSQL really, for the most part, is not necessarily vendor lock-in, right? A lot of those NoSQLs use HTTP as your interface. So you can very easily create a proxy and say, hey, I want to start using a key value store. Or I can keep using Couch and do dark reads and dark writes really easily to transform over to one system or another. Now, going from key value or document to columnar may be a little bit hard, but for the most part, it's not horrible, and it's not like, oh, I've got to go teach all my guys some new thing. They're all able to work with very common patterns and designs. So everybody's been voting 11-0 social. So, and NoSQL 9-1, and CRM 8-1. So in this throwdown, I think NoSQL won. So one more thing, and this is something that is something to think about. So here we're going through databases and we're going to use cases and thinking like in a concept of one database, one application, right? But there's something new that's coming around, and I don't know if this term is a term or not, but basically NoSQL polypersistence. So poly means many. So the thinking of having many different NoSQL databases to combine to create a very powerful structure, and really can succeed sometimes your CRM if you know that it's going to be so big that you're going to run out of that vertical scale space. Then you could entertain an architecture where you say, hey, I'm going to use Redis for my ad hoc stuff. I'm going to use CouchDB for my document, my truth, because it's durable, it's built. And then I'm going to use Neo.j for my relationships. And I'm going to make these pieces talk and act as a single database. That's kind of interesting because that can be easy to manage and easy to grow and scale without having to go to IT and say we need a couple more gigs of RAM. Oh, you need a computer. Oh, okay, that's going to be $250,000, right? With licenses and everything. So anyway, that's something to think about. I don't know of. I mean, I know all the big guys are doing this, right? Because they got so much data. Facebook still runs on MySQL and still uses Cassandra and uses all kinds of other stuff. Twitter uses all kinds of databases on the back end. As far as starting a single app or a simple app, this is probably overkill. What I usually recommend if you're just getting started is to start with something like CouchDB or MongoDB, because you probably, if you're just getting started, you probably don't really know your schema very well. You probably will need users to give you feedback. And if you get it and it gets locked down and you like say SQL or NoRM is the best thing, then it's real easy to switch. But once you commit to MySQL, you're stuck. And if users start halfway down, start requesting crazy things, and you put a crazy query together, next thing you know the whole system slows down, well, they're going to be upset. And you're going to say, well, if you didn't request that feature, everything would have been fine. But that doesn't work. So anyway, to summarize, I think the biggest thing to take away here is really there's no easy answer for these things. So go through and understand your problem. Understand the problem you're trying to do. But more than that is go through all these databases, as many databases that you can get your hands on and experiment. The more you learn about databases, the easier it is to do this. So it's easier to say pick the right tool for the job. But if I only know SQL, and someone says, well, you should be using Mongo. Well, I don't know Mongo. So how would I make that risk to take that? So take your time, get your developers out, and experiment with all of these databases. They're very easy. They're all open source. And then also think about the vendor lock-in. Sometimes vendor lock-in's a good thing, right? Sometimes, you want to say, hey, Oracle, here, you do all the database stuff. I'll pay you. I don't want to think about it. I just want to think of my app. Sometimes that's okay. But think about it. It is a real issue. And then think about scale. Now, everybody wants to get 10 million users, but really try to be realistic and understand where your scope is and where your scale is, and sort of, be realistic with that. And think about your developer skill set. If you're making a decision and your developers don't buy into it, it's not going to work, right? So if you say, hey, we're going to use Couch, and your developer says, I don't know how to use Couch, I'm not going to use Couch, no matter how good a fit it is, it's not going to work. Because they're going to come in and they're not going to know it, and they're going to come in and use it in a non-performant way, right? Play with every database you can, like I said. And questions? Yeah.
You're downplaying the lock-in of NoSQL databases, but I would think you'd be locked in not necessarily at the data access language kind of level, but at the conceptual level of what you're using it for and what you're designing the app around. I wouldn't think that these things, especially if they're in different categories of document versus columnar or whatever, that they'd be plug and play.
Yeah. Again, you're right. It's not simple, and I don't mean to insinuate that, but it is simple to move from Couch to Mongo. It is simple to move from AWS Dynamo to Riak, right? So both of those are built off the Dynamo paper. Couch and Mongo are pretty much built off of document databases. So you do have some leverage there. Again, if you're like hosting things on AWS and you want to use their services, but you're like saying, okay, one day I'm going to grow up and get big and I want to go into my own data center, then it's a lot less of an issue to use like an AWS Dynamo and say, hey, we can cut over to Riak, versus using a database that Amazon doesn't support, let's say Postgres, and managing that yourself, hiring DBAs to do that, and then move it over. So you're still there. So, but it's relative, right? It's relative. You can make an argument either way. I just know that SQL, you're pretty much locked in.
Got one for you, Tom.
Yep.
In your experience, have you seen the analog of stored procedures in the NoSQL world? Can I use my NoSQL database engine to distribute some of the computation?
Yeah. You can, and a lot of folks leverage Redis that way, right? So they use Redis as their computation, managing indexes, doing just wicked fast searches, full text searches, things like that. Lucene is another one. But an interesting point with that, with SQL, one of the things with SQL databases, I think what I've seen so far is that developers have moved away from the strength of SQL databases, right? With ORMs and MVC. So you're building things and you're not leveraging stored procedures. You're not leveraging views. You're not leveraging all the power of the SQL database. If you go with a relational database, commit and leverage all of that, because that'll save you so much lines of code, so much time, and so many issues. And oftentimes I think we're stepping away from how powerful they can be.
Can you talk a little bit, you touched on it, about sort of the ease of administration once you get into production? I know from experience like MongoDB,
Right.
It's great when you're sort of playing around with it in development, but then when you try and set up something that's going to scale in production and try and configure it properly on master slave and put it on AWS, it starts to get pretty complicated. And
Right.
companies like Mongo Labs charge a lot of money to support that open source
Right.
software.
Right. Yeah. There's all kinds of kids in NoSQL. So MongoDB's when you get big, I mean, Tengen is very much a big supporter of supporting that, helping you grow that big infrastructure, because it is very difficult. To run a Mongo in the cloud, even if you're a very small footprint, you still have to run 3 servers, and then you have to have this little gateway server that determines who's master at any given time, right? And so that can get a little complicated and a little bit larger for a developer to deal with. So, but at the same time, Couch is like super simple. If you want to put it up in the cloud, you just fire up a server, install it, and do a couple of security commands, and you're done. And it's easy to back up. All you do is rsync to S3 or something. So Riak is designed to be zero in administration. Yet there are some key value stores that are not zero administration. So it really is like sort of like really play with each one and understand its strengths and weaknesses. Mm-hmm.
I think you're seeing a lot of the SQL vendors take on NoSQL features. Do you see this kind of hybrid thing approaching out of the SQL vendors to deal with the NoSQL opportunities? Yeah,
it's really interesting, and I haven't really got to play with it yet, but Postgres embedded the V8 engine, right? Mm-hmm. And Postgres is really an interesting animal. They're really, really strong in the SQL area and very, very much into math. But they've embedded a lot of features from NoSQL. So I think Postgres in general is one, if you want your cake on both sides of the table, is one to look at, right? So if you need, some relational structure, but then you have some document database, that's something to look at. But it's still sort of fresh what they're doing. I don't know if it's fully vetted yet, but it is exciting to see them move into that space.
Yeah, they actually have a columnar engine too that they can run or back all of the data with.
Yeah, they may be the polypersistent data store, right?
So we'll take one more question before we wrap up. If anybody's got the last one.
Do you have any?
Yeah.
Do you have any thoughts on NoSQL?
On
NoSQL?
NoSQL? No, I don't. I'm not that new. But if you do want more stuff, this is a great database, book. A great book about databases. 7 databases in 7 weeks, and this really will drive you through 7 other databases I talked here and walk you through exercises to really play for each one, and then at the end it gives you a strength and weaknesses summary of each one. So this is a great way to get to know more about this topic. All right?
That must be a time up there.
Yep.
Well, thanks, Tom.